Hello everyone, welcome to the mathematics in my channel. In this video, we are going to solve this nice repeated infinite series. So how to begin? Well, here first we have n1 is equal 1 to infinity, then n2 is equal 1 to infinity, then n2022 to infinity. So we know here sigma notation repeated 2022 times. So first here 2022, here also 2022. I'm going to generalize this sum by taking, instead of 2022, I'm going to take k. So we can rewrite our sum n1 is equal 1 to infinity, sum of 1 to infinity. This is going to here now we have nk is equal 1 to infinity 1 over, here now we have n1 n2, this is going to nk, and n1 plus n2 plus this is going to nk. Okay, now what can we do? Okay, let's consider this part. So I'm going to introduce an integral. So if we take integral from 0 to 1 x to the n1 plus n2 plus this is going to nk minus 1 dx. So if we integrate, we know using general power rule, we have x to the n1 plus n2 plus here nk, then minus 1 plus 1 get cancelled over n1 plus n2 plus this is going to nk, limit from 0 to 1. Now if we apply limit, we know we have 1 over n1 plus n2 plus nk. Now here we have also this term. So instead of this part, we can plug in this integral. So here sum n1 is equal 1 to infinity, sum n2 is equal 1 to infinity, and we know this is going to nk is equal 1 to infinity. Then here we have 1 over n1 n2 and this is going to nk, and instead of this part we know we have an integral from 0 to 1 x to the n1 plus n2 plus nk minus 1 dx. Okay, then we know we can switch the integral sign and sigma notation. So we can write integral from 0 to 1 sum of n1 is equal 1 to infinity, sum n2 is equal 1 to infinity, and we know here nk is equal 1 to infinity. Now here 1 over n1 n2 nk, and here we have x to the n1 plus n2 plus nk minus 1 dx. Okay, then here integral from 0 to 1. Now here we have x to the n1 plus n2 plus nk minus 1. So we can write here x to the n1 plus n2 plus nk times x to the minus 1. It's mean 1 over x. So 1 over x we can write outside of the sigma notation. So 1 over x sum 1 to infinity, again 1 to infinity, and here sum nk is equal 1 to infinity. Now this part we can write x to the n1 times x to the n2 times x to the n3 times this is going to x to the n k, here k, over here this part n1 times n2 times n3 times nk, and here finally dx. Okay, then let us simplify. So integral from 0 to 1 over x. Now here x to the n1 over n1, x to the n2 over n2, x to the n3 over n3, and here n1 is equal 1 to infinity, n2 is equal 1 to infinity. So we can write here sum of n is equal 1 to infinity, x to the n over n. Now we know we have sigma notation series k times, so here k power dx. Okay, then here we have well-known infinite sum, because we know natural log of 1 minus x is equal to minus sum of n is equal 1 to infinity x to the n over n. So we can plug in. So here integral from 0 to 1. Now instead of this series, we can write minus natural log of 1 minus x raised to the k power, here we have x, so x dx. Well, now we know the definite integral independent of the variable. Integral from 0 to a f of x dx is equal to integral from 0 to a f of a minus x dx. So we can write our integral is equal to integral from 0 to 1 minus natural log of 1 minus x. So we have x, so minus natural log of x raised to the k power over 1 minus x dx. Now we can take a substitution. So here in the numerator we have minus natural log of x. So minus natural log of x is equal to t. Then we know natural log of x is equal to minus t. So we can isolate the x. X is equal to e to the minus t. If we differentiate, we have dx is equal to minus e to the minus t dt. So we can plug in. Here we should change the boundaries. Lower limit when x approaches 0, here infinity. When x approaches to 1, upper limit we know 0. So minus natural log of x we know t, so t to the k power over 1 minus x we know e to the minus t dx we know minus e to the minus t dt. Okay, then we can switch the lower limit and upper limit like 0 to infinity. So when we switch the limit, this minus sign get cancelled. So we have t to the k times e to the minus t over 1 minus e to the minus t dt. Okay, then we know we can represent this part as an infinite series. So we have integral from 0 to infinity t to the k times here I am going to take r is equal 1 to infinity e to the minus r times t dt. Okay, then we can switch the sigma notation and integral sign. So here r is equal 1 to infinity integral from 0 to infinity. Now here we have t to the k times e to the minus r times t dt. Now again we can take and substitution. So here r times t, so r times t is equal to v. Then we should differentiate. R times dt is equal to dv. Then we can plug in. So we have sum r is equal 1 to infinity. Now we know integral limit also 0 to infinity. Now t, we know here t is equal to v over r. So v to the k over r to the k. Here e to the rt we know v, so e to the minus v, and dt we know dv over r. So we can simplify here r to the k, here r. So r is equal 1 to infinity 1 over r raised to the k plus 1 power integral from 0 to infinity here v to the k times e to the minus v dv. Now we know this is the definition of gamma function, gamma of k plus 1. So we have now gamma of k plus 1. We can take outside the sigma notation. So gamma of k plus 1 times infinite sum r is equal 1 to infinity 1 over r to the k plus 1. Okay, now gamma of k plus 1 we know k factorial, and this is the definition of Riemann zeta function, zeta of k plus 1, zeta of k plus 1. Okay, this is the generalized answer. So our question here, instead of k, now we have 2022. So if we take our sum is equal to s, now we know s is equal to k, we know now 2022. So 2022 factorial times zeta of 2023. Okay, this is the answer. So I have another interesting things to show you, because here we know k 2022. If we take k is equal 1, when k is equal 1 we have only one series. So when k is equal 1 we have n is equal 1 to infinity. Here this is the series. So when n is equal 1 we have one series, and here one term, here also one term. So n times n square. So we know 1 over n square is equal to, now according to generalized answer we have when k is equal to 1 factorial times zeta of 2. 1 factorial we know 1, zeta of 2 we know 5 square over 6. Okay, then if we take 2 when k is equal to 2, k is equal to, we have 2 series. So n is equal 1 to infinity, and we can take k is equal 1 to infinity. Then we know here we should take this 2 part, and here n1 plus n2. So we have now 1 over n times k, n plus k, and we know the generalized answer k is equal to 2. We have 2 factorial times zeta of 3, zeta of 3. So we have 2 times zeta of 3. K is equal to 3. We have sum n is equal 1 to infinity, k is equal 1 to infinity, r is equal 1 to infinity, 1 over n times k times r, n plus k plus r is equal to we know now 3. So we have 3 factorial times zeta of 3 plus 1, so zeta of 4. 3 factorial we know 6, so 6 times zeta of 4. Okay, if you like this type of videos, please subscribe this channel. Thank you for watching.